In this video, we're going to derive the divisibility rule for 11. Actually, I'm going to state what it is and then we're going to prove it. So basically, if you have a number 7, 2, 3, 4, 5, 8, 1. If you add and subtract the numbers, the digits, you alternate 7 minus 2 plus 3 minus 4 plus 5 minus 8 plus 1. So you have 5 plus 3 is 8, minus 4 is 4, plus 5 is 9, minus 8 is 1, plus another 1 is 2. Okay, if this number is a multiple of 11, then this number is a multiple of 11. If this number is not a multiple of 11, then this number is not a multiple of 11. Okay, so let's formally state that. Any number can be written in the form, any integer can be written in the form of a sub n times 10 to the n plus a sub n minus 1, 10 to the n minus 1, all the way down to a1 times 10 plus a0. Now, 11 divides that number. This is the theorem we're going to prove. If and only if 11 divides an minus 1 plus a sub n minus 2 minus all the way down to a0 minus all the way down to a0. Now, a0, I'm not going to know the sum. Sorry, if it's plus or minus. Why? If you have a 3-digit number, it'll be 7 minus 2 plus 3. But if you have a 4-digit number, it'll be 4 minus 3 plus 5 minus 7. The last digit can be plus, the last digit could be minus when you do the alternating sum and differences. So I don't know what that sign is, but it doesn't matter. Okay. Now we are going to prove this by induction on n, the power of the leading power of 10. Proof by induction on n. Well, if n is 0, k is just a sub 0. Okay, so now 11 divides k if and only if 11 divides a0. But that's exactly right, because it's this digit minus the next digit plus the next digit minus etc. You know, if it was 7, 2, 4, you wouldn't have a problem doing that. But if it's just 4, well then it's just 4. Okay, so it is correct. But that's so not good looking. Let's try another one. Suppose n is 1. Well then k would be a1 times 10 plus a0. But I'm going to rewrite this differently. First of all, I want to write it differently right away. Instead of a1 times 10, how about just 10a1? Now, I want to find a multiple of 11 that's closest to 10. And that multiple of 11 will be 11. Now, the multiples of 11 are 0, 11, 22, 33. Which of these numbers are closest to 10? 11. So I'm going to make that 11a1, but then I have to justify it by taking away a1. Okay, plus. Now that's 1a0. Which multiple of 11 is closest to 1? And the answer is 0. That is, I'm just going to leave it as a sub 0. In other words, I could have said that it's 0 times a0 plus a0. That will give me a0. But I will just say plus a0. All right. Now, (11) divides k if and only if 11 divides k. And this is how I want to write k. It is, let me just write this slightly different. This is equal to 11a1 minus a1 minus a0. Okay, so that's just k. So if and only if 11 divides 11a1 minus a1 minus a0. I really wanted to have a1 minus a0. Now, since 11 divides this, the only way 11 is going to divide the subtraction is if and only if 11 divides a1 minus a0. But that's what I should get. That digit minus that digit. 11 divides k if and only if this digit minus that digit, well, 11 divides it. So that worked. Let us even try it one more time. Suppose n equals 2. So then k will be 10 squared, which is 100 times a2 plus 10 times a1 plus 1 times a0. And here are, maybe up there is not good. Let me put it down here. Here are the first few multiples of 11. 0 times 11, 1 times 11, 2 times 11, 8 times 11, 9 times 11, and 10 times 11. Now, which of these multiples of 11 is closest to 100? The answer is 99. So I'm going to think of 100a2 as 99a2, and to balance it, I better add another a2. So this I have. I have it right there. Now, 10. Of these digits, of these numbers, 11 is closest to 10. So I'm going to think of 10a1 as 11a1, but I should only have 10a1. I'll take away an a1. Plus, now there's a 1 here. That's closest to 0. So, I can have 0a1 plus a1. Well, that's just a1. a0, I mean. Okay, now rearranging this. This is 99a2 plus 11a1 plus the non-multiples of 11. a sub 2. We're adding a negative a1. That means take away a1 plus a sub 0. But this number, by design, we can factor out an 11. Okay, so now we are in good position. This number k is the same as this number. 11 divides k if and only if 11 divides k, which is 11 times 9a2 plus a1 plus a2 minus a1 plus a0. Okay. Well, 11 divides this. The only way 11 is going to divide the sum is if and only if 11 divides A2 minus A1 plus A0. But that's just what we wanted. That digit minus that digit plus that digit. Got it. This is really working. It looks like it's true. Okay. So now, our assumption. N equals, now I used K already, so I'll call it Q. That means K is equal to A sub Q 10 to the Q plus A sub Q minus 1 10 to the Q minus 1 all the way down to A1 times 10 plus A sub 0. And we assume that 11 divides K if and only if 11 divides AQ minus AQ minus 1 plus all the way down to A0. I don't know if it's plus or minus. If the highest power of 10 is Q, then 11 does divide it. Now, please understand that any one of these, or all of them, can be 0, except this one. We're assuming it's really Q plus 1 digit. It's going to have Q plus 1 digits. You know, if it's 10 cubed, well, that means it's at least 1,000, so it has 4 digits. Okay, in other words, it might be 7 times 10 is 3 plus 2 times, or 10 squared plus 5 times 10 plus 11 times 1, which is 7 times 4 times 1. Be 7,254. If the highest power is 3, you have 4 digits. Why? Because when the power is 0, like 3 times 10 to the 0, that's 3. Ooh, it has 1 digit, but the power is 0. It has 1 more digit than the highest power. Alright, so now what we want to show is, and this is it, this is the hard part, we must show that for n equals q plus 1, that k, if k is equal to a q plus 1 times 10 to the q plus 1 plus a sub q 10 to the q all the way down to a1 times 10 plus a0, that 11 divides k if and only if 11 divides aq plus 1 minus aq plus a sub q minus 1 minus all the way down to plus minus a sub 0. We need to show this. We need to show this. Okay. That's what we want to show. So, let's see how we can show this. Now, we know that 11 divides that. We know I didn't mean to say that. We know 11 divides what I just put in green, AQ 10 to the Q, all the way down to A110 plus A0, if and only if 11 divides that. This is what we know. AQ minus 1 plus all the way down to plus minus A0. That we know. question is, does 11 divide this? Does 11 divide that? Or when does 11 divide that? When does 11 divide that? Now, a cubed plus 1 times 10 to the cube plus 1. Now this is where you have to be clever. And it seems to always be the case in these induction proofs where at some point you have to be a little bit clever. This here is a cubed plus 1 times 10 to the cube times 10. In fact, let's even bracket it up like that. But 10 is 11 minus 1. This is a cubed plus 1 times 10 to the cube times 11 minus 1. Distributing, I get 11 times a cubed plus 1, 10 to the cube, minus a cubed plus 1, 10 to the cube. Okay, now 11 divides this, 11 divides this, if and only if 11 divides any other way of writing this, which is that way. 11 times a cubed plus 1 times 10 to the cube minus a cubed plus 1, 10 to the cube. Well, clearly 11 divides this. So 11 is going to divide their subtraction if and only if 11 divides a cubed plus 1, 10 to the cube. But this is if and only if 11 divides a cubed plus 1, 10 to the cube plus 0 times 10 to the cube minus 1 plus 0 times 10 to the cube minus 2 all the way down to 0 times 10 plus 0 times 1. But the highest power is only q now, and we assumed that whenever it's q, it's 11's gonna divide this number if and only if 11 divides this coefficient, a cubed plus 1, minus that coefficient plus that coefficient, all the way down to plus minus the last coefficient. But that's if and only if 11 divides a cubed plus 1. Okay. So, what do we have here? We have that 11 divides k if and only if 11 divides a cubed plus 1, 10 to the cube plus 1, plus a sub q times 10 to the cube all the way down to a sub 110 plus a sub 0. Now, let us bracket it like this. This plus the rest. But this is if and only if 11 divides a cubed plus 1 and 11 divides this. And 11 divides this if and only if 11 divides AQ minus 1 plus dot 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 up to A0. Well, if 11 divides this and 11 divides that, then 11 divides the difference. AQ plus 1 minus this. And I hope the minus becomes apparent in a moment. The minus is there. I mean, I could have said add, but I'd rather not, because I want this to be AQ plus 1 minus AQ plus AQ minus 1 minus all the way down to, maybe I'll say minus plus A0. Okay, so we got what we wanted. 11 divides K if and only if 11 divides that. And that completes this proof. If you just love videos like this, please subscribe to my channel. Leave a comment, good or bad. If you have a theorem you just can't wait to see proven, leave it in the comment section. I'll try my best to prove it. Most of all, watch and learn.